Hello there, and welcome to another Minecraft video. This one's going to be a little different. In light of me playing on my old survival world, which a few of you may be familiar with, I'm trying to do a big project where I kind of redstonify the world, make a whole bunch of automated systems, make my life easier and whatnot. And it's taking a lot longer than I thought it would take. So what I thought I'd do in the meantime, since I've been learning more about redstone myself, I thought I'd share with you guys little tutorials on how to use redstone. Now, I want these to be a little different in that I don't simply tell you what redstone components do what. Hello, piggy. Oh, cows. Oh no. But I want to basically not so much tell you guys what the components do, but more so actually help explain to you guys how to build circuits, how the logic actually works, the basic fundamentals of building circuits. I'm currently an electrical engineering student, and I know those skills I've learned in class have definitely helped me to understand how redstone works, so I'm hoping I can kind of share some of that knowledge with you guys. That way you not only know what you're doing, but you understand it, so you can create all sorts of redstone stuff on your own. So let's go ahead and get started. So first off, what do I mean by logic? Well, in every redstone circuit, no matter which one you're building, there are always going to be three common things. You're going to have an input, which in this case is this lever. You will have the output, and then you will have the logic in the middle. And this is the part that's difficult. This is the part that actually takes brain power, because this logic here will determine what your output gives. So if I really wanted to, I could change this repeater a little bit. If I did this here, and I'll go into more depth of how each component works and how you can use them a little later. But if I were to change the logic up a bit, I can determine the output, right? So that's what we're working on, the logic here. What is this logic? Basically, the logic interprets the input in some way, or I guess in this case the inputs in some way, and gives you a specified output. Okay, so how can we make logic, right? How can we make that logic work? Well, in real-life circuits, there are logic gates, and these logic gates are very simple tools used to interpret inputs. There are, I don't know how many logic gates, I know of at least 7 or 8, but these simple logic gates can be used to build pretty much any circuit you want. So I'm going to introduce you guys to 3 of the most simple ones. And I'm going to explain how the powering and the redstone circuits work as of now. But right now I just want to introduce to you guys the basic concepts of the logic part of the redstone. Because redstone, in a way, the simple ones are kind of self-explanatory. But if you guys can improve on your logic, you should be able to vastly improve the redstone circuits which you're building. So the first one we're looking at here is called an AND gate. And this one is pretty simple. This will only turn on, and I should fix this. This is wrong, my bad. There we go. But that output, this redstone lamp here, this will only activate when both of these levers are powered. So if I flick this lever, you can see the redstone dust kind of flicker there on the lever when I activate it. So that's activated, but it's not turned on yet. And I can do the same thing with this lever. I can activate this input, but that won't work. So this will only turn on when I activate both this first lever and the second lever. Usually they're called inputs A and B, so I would say this will turn on when A and B is activated. Next one is the OR gate, and this one is much simpler. This will turn on when A or B is turned on. Now it'll turn on when there's both. There is a separate logic gate that will only activate when one is on and one is off. If the two inputs are the same, then it'll turn off. That's a little more complicated. We'll get into that later. It's not that complicated, but it's not really something you necessarily need to know. But OR gate's very simple, by far the easiest logic gate. And then finally we have the NOT gate. This does the exact opposite of what those do, in which it will invert the signal. So right now this lever is powered off, but because of this redstone torch, the output is on. So when I turn on this lever here and flip the switch, it will deactivate. And I'll explain a little bit how this mechanic works later. I know I keep saying that a lot. I might do it in the next episode, just because, like I said, in this episode we're just focusing on the actual building of logic. In the next episode I believe I'll work on how powering works, and then we'll just take steps from there. But yeah, these are the three very, very basic logic circuits, and you can use these three to build pretty much any sort of logic you want, and I'll give some examples here. So let's say I wanted to get a little more complicated. Let's say that I would want something to activate when the middle three are turned on, right? But I don't want to just build a bunch of this stuff, right? I want to make this as simple as possible. I want to compress this down. So how can I do that? So we can take advantage of this inverting gate we have here. And I'll try to color code this so you guys can see which gates are going where. But what we can do, very simple. We will have an inverted gate here at the very end. And this will be our output, right? What we want to do, we're going to set all these on for now, or we'll set all these off. And we will just wire these up directly to the inverter. Okay, so all of these have the potential to turn that off, which is what we don't want. Right? We want all of these to be off in order for this to turn on, right? So how can we do this? Now let's look at this first one. When this is on, I want that to turn on, right? Problem is, it does the exact opposite. So I can make this an inverter, right? So that when this turns on, it turns off. See? So that's what we wanted to do. Now what about with this one here? Right. Let's say that one's on. This one, I'm thinking we just leave it. It's a little more difficult to tell, so I'll unplug this from the circuit for now, since we know what this is going to be. I want this to turn off when this turns on, right? Because this shouldn't affect the output in any way, shape, or form. And this does exactly what we want it to, so we can leave this alone for now. What about this one? Well, this one did the exact same thing as that first one we did. So we'll simply make this another inverter, right? And then hopefully you guys can see there's a pattern. That one we'll leave alone, and then this one will do the exact same thing. So now, if I were to connect all these back to the circuit, we should have a system where no matter what we do, it won't turn on until we turn on the middle three. So this is about as simple as any combination and logic is going to get. So let me explain what's going on here. So we have a bunch of OR gates, right? These two are OR gates. That's this here. So I can put red here if that helps. So these two are basically acting, that's yellow. These two are basically acting as OR gates. When one turns on, the other will always share the same. Now, the other three here, I just noticed it's Christmas time, and it looks Christmassy. What do you know? What are the odds? But these other three here, these are all inverters, right? Because these are all activated now, right? And we'll take those off just to help simplify it. I can turn this off. That'll deactivate this redstone torch. But those two still need to be turned on in order for that center to be turned on. Right? Because when we turn on this lever, it will deactivate this redstone torch. And then these two just help make sure that if someone inputs the wrong signal, the light will turn off. So in other words, when you guys are making some sort of logic with multiple inputs, and let's say you want it to be a combination, if you want the combination to activate when a certain input is on, you can put a redstone torch there to invert the signal. If you want to activate when it's turned off, you can simply put down a redstone dust and just leave it as it be. Bring everything together, bring it straight to an inverter, and there you have it. That is all logic. This here is all the logic. We have our output, we have the 5 inputs, and we have all the logic in the middle, right? So I hope I explained that clearly. The next video I will definitely go more into depth on powering redstone, like the redstone torches, how exactly that turns off when the lever is turned on, how this block is being powered by that redstone dust, all that good stuff. So I hope this video at least somewhat helped you guys in being introduced to redstone logic and the logic of circuit building. And we'll go a lot more into depth starting with the next episode. But overall, this is about as simple as it gets. The next videos will definitely get much more harder. And we're going to go into stuff like piston doors and automatic farming, flying machines, all that fun stuff. So, I hope you guys enjoyed this video. If it liked you, oh god, no. Please not today. If it helped you, please like and sub or comment. Just let me know if this helped you guys understand the logic of circuit building. And I will talk to you guys in the next video. Bye.